Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of robotics and automationnews.com. Today I'm interviewing Molly McCarthy of Veo Robotics, a startup company which uses a variety of cameras and sensors to transform traditional industrial robotic arms into what are effectively collaborative robots. So let's start with the introduction of yourself and your company and the challenge that you're solving.
Well, first, thank you for having me. My name is Molly McCarthy, and I am the Vice President of Sales and Business Development for Veo Robotics. Veo Robotics is a startup in Waltham, Massachusetts, which is right outside of the Boston area. And the company was founded in 2016, and we are releasing our first product, FreeMove, this year. So FreeMove is a robotic vision system which enables the big industrial robots to be collaborative. So as anyone in industrial automation knows, there's really two main types of robots in this space. And the first is the big traditional industrial robots that have been around for a while now. And these are very powerful tools, but the very thing that makes them so powerful is also the thing that makes them dangerous. They're big, they're strong, they move fast, and so they have to be caged, and quite often they have to be fully powered down before a human worker can even enter the space. And that is not the best situation, because in a factory, the most flexible tool that you have are your human workers. And they're good at things that robots are not good at, dexterity and judgment. And so having to separate these two things means that you either miss out on opportunities to use robots where you would like to, or you end up having to over-engineer applications because you're having to automate things that really are better suited to a person. So that's where the next group of robots comes in, which is power and force limited robots, or cobots. And they have had a lot of success in the market. And the benefit is that they can work alongside of humans. And so that has enabled people to start to use robots in some places where they couldn't before, and that's great. But the way that they work is they have to be safe on contact. Power and force limited means that they promise to stop if they hit you, and that it won't hurt too badly when they do. And so naturally, there are some limitations here. They can't be very big. They can't be fast. They can't carry a heavy payload, and they can't carry anything that's dangerous. And when you walk around factories like I do, automotive and any kind of durable goods manufacturing, appliances, things of that nature, you don't see very many of them. And the reason for that is that the tasks that the robots are doing in those factories, they really just can't be done with a power and force limited robot. So we're really looking to bring the best of those worlds together and give manufacturing engineers the ability to use the big industrial robots that they know and love, but also make them safe to be used around people. And we think being able to combine the strengths of humans and the strengths of robots together in single applications is really going to give manufacturing engineers a level of productivity and flexibility that they've just never had before.
So just to follow on from what you just said, you gave us an overview. How do you actually implement the kind of solutions? How does it work?
Sure. So with the big robots, you can't use power and force limitation. And so we use a different, well understood standard for collaboration, which is speed and separation monitoring. And this is a standard, ISO standard. And so really what we do is FreeMove at a high level. We monitor a work cell in 3D. And if any part of a human gets close enough to a robot, we slow and stop the robot in order to ensure that it comes to a complete stop before a human could ever get there. So more specifically, what that means is, it starts with time-of-flight cameras, which are put at the periphery of the work cell. And we're actually building our own time-of-flight cameras that can be used in industrial settings and that can eventually be safety rated. So we're working on that. And these time-of-flight cameras, they provide depth images of the work cell. And those depth images then get sent to the free move cortex, which is, our fail-safe industrial computer. And free move cortex then fuses these images together and builds out a semantic representation of the work cell. We then classify what we see in that semantic representation. And it starts by first identifying things in the work cell that are what we call recognized objects. So this is the robot, the workpiece, end effector, so things that you can upload through CAD in the setup stage. And then also anything that's part of the static background. So we do a backgrounding step. And so if you have a table or fences, those sorts of things, we take those into the equation. And so those become the recognized objects. We then identify what we call unrecognized objects. And so these are things that are in the space that you haven't already said are supposed to be there, as well as anything, any occlusion, so any space that we cannot see. So it isn't just stuff that we do see, it's also places where we can't see. So maybe that's under a table or something like that. And so for those occlusions, we also mark those as unrecognized objects. And everything else in the space is empty. So once we've done that, we say, okay, for the unrecognized objects, which of these things is big enough to be a person? And this is something that is outlined in the standards. We didn't make this up. And it's actually quite small. It's 25 centimeters. It's a cube that's basically 25 centimeters on a side. And if there is an object or an occluded space of that size that a person could hide behind, then we assume that that is a place where a person could be, and we will control the robot off of that. And this is really important because when I talk to people, they often think that we are identifying humans and separating them from other things in the space. And there are tactics to be able to identify a human, but machine learning. But it's probabilistic, and it's not something that you can use in industrial applications. And it's certainly not something, quite frankly, it's just not safe. It's not something that we could do with our product in order to get safety certification. So we don't try to figure out, what's a box and what's a person. We just want to know anything that is actually big enough to be, that a person could be inside. So once we've done this, we've now mapped and classified the work cell. And at the same time, we then identify all the places that the robot could go on that particular cycle. So we have information about the robot, the position from the robot controller, and we're able to confirm that information with our sensors. And from there, we assume worst case scenario. So all the places that the robot could go at max acceleration. And that builds out what we call the robot future cloud. And it looks just like that. It looks like a ball that's on the end of the robot. And so those are all the places that the robot could go on that particular cycle. So now we put those two things together and we implement speed and separation monitoring. So we dynamically monitor where the robot is and where anything in the work cell that could be a person. And if that potential human gets close enough to the robot, per the standards, then we actually slow and stop the robot. We issue a protective stop, category 1 stop, and we ensure then that that it is safe. So that's a lot of information. I'll try to kind of summarize what we do in a slightly different way. So basically, assuming the kind of conservative estimates for how fast a human can go, and kind of worst case scenario for where the robot goes, our system essentially is asking a question, and this is at 30 frames per second. And basically, our system has to say, if I don't take action between now and the next cycle, are all of the possible future states safe? And if the answer is yes, then we take no action and we let the robot continue moving as it always would. If the answer is no, and there's any possible future state that could be unsafe, then we issue a protective stop and we stop the robot.
You've sort of touched on the benefits and maybe suggested some of the applications in the abstract. Obviously, we're talking about robots and in factories, and the applications can be many and varied. But what are some of the maybe the examples or maybe the benefits that you can tell us about?
Sure. So it really starts with customers being able to really use the strengths of both the robots and people to accomplish their goals. And so that could be, for example, improve cycle time, or on a limiting step, talk time, where instead of a person having to retrieve a large piece from line side storage, they're able to actually use a robot to do that heavy lifting, and then the human can come in and do a fastening step or something that requires human dexterity. So that could be a situation where it really is about improving talk time. A simple one is actually one that we hear a lot, has to do with reducing downtime. So right now, and in fact, one customer a few weeks ago that we were talking to, which is a large automotive component supplier, had an application where 50 times a month, somebody had to actually enter the work cell and basically bang a conveyor to get things moving again. And it was a very sophisticated application, but that's just the way that worked, and we hear about this all the time. And so in order to do that, you have to call maintenance, you have to power down the cell, you have to go through a lockout tagout procedure, and it takes a lot of time. And so with our system, somebody could just walk into the cell, the robot would stop, remain in a safe state, the person could do what they need to do very quickly, wouldn't have to call maintenance, and then they could walk back out again. And so just being able to reduce the downtime is a huge advantage. I mean, we've heard from appliance manufacturers that it's it can be $3,000 a minute in downtime, and in automotive it's way more than that. It's can be $50,000 a minute, and so we're talking real money. So it really just depends on the application, and then there's a lot of flexibility. So there was a customer that we worked with, also actually an automotive component supplier. We work across industries, but automotive certainly is a big one. And we did a trial in their lab last year, and they were doing a emblem polishing step for parts for service. And in this step, because the parts were changing over every week, they really couldn't automate it. You just can't do fixed automation with something that's changing on a weekly basis. And so people were having to do this polishing step, and it's bad ergonomics, and the quality was poor. And so they wanted to get a robot in there to do that. And so, they set up the application with our system. And what that enabled was a human to actually go over to the dunnage. People are really great at picking parts out of, inflexible flexible packaging that aren't in an exact location. And then the person would fixture it to a table, step out of the way, the robot would perform the polishing step. And while that was happening, the worker went to the other table and basically did the same thing. And so this enabled them to, to basically, get a robot in and improve ergonomics and improve quality. So fewer parts were actually being sent back. So that's just something that they couldn't have done, with a robot before. You really needed the person to be able to take the parts, fixture them to the table, and put them back into the packaging. You just couldn't do that otherwise.
In terms of the roadmap towards whatever it is that you want to achieve, how do you anticipate that unfolding, if you like?
Sure. So I'll start a little bit with, kind of how we plan to go to market. So we see ourselves as, we're another piece of industrial equipment, and so we intend to go to market working very heavily through, systems integrators and to some extent, direct to end customers. So we are working with the big four robot OEMs. We integrate with their controllers, so Fanuc, Kuka, Yaskawa, and ABB. But we do go to market independently of them. And in terms of where we are right now, our product will be released at the end of this year. And but we are working with customers, mostly end customers right now, on what we call an application development kit, which is basically it's an early version of the product that customers can use in order to start playing around with the technology, designing applications, understanding what the ROI is, really in advance of our product launch. So those are select customers that we're working with. But really what we're working towards is our, full product release later this year. And then, safety certification, performance level D, category 3 safety certification a few months after that.
The safety certification, you
Yes.
mentioned that before earlier. What are the details there?
Yeah, absolutely. It's definitely one of the first questions that customers ask us. Our system, at the end of the day, is being used to safeguard hazards. And so as they perform a risk assessment, as part of the application, they need to understand that we are safe and that we are reliable. And so the way that we're doing that is pursuing, safety certification for, as I mentioned, category 3 PLD. So this is something that we have been focusing on from the very, very beginning. Scott Denenberg, who is our chief architect, actually participates in the safety standards, specifically for ISO 10218 for collaborative work cells. And, we have been working alongside, TUV, along the way. So, really this is just something that is, super critical, for our customers and for us, quite frankly. So it's something that's very much a core part of our, product strategy and our go-to-market strategy.
We have a lot of engineers reading our website and obviously in robotics, and this is just right for us in terms of a subject matter. But we also have people who have similar backgrounds to you, sales and finance, investment and things like that. People are looking to invest in startups, and people are interested in how business is going with various companies, new companies that they may not have heard of before. I noticed on LinkedIn that you have, I think, 40 plus employees, which is quite a large number, I think, for a startup. I mean, as you know, a vast majority of companies are fairly small businesses in manufacturing. But I was wondering if you could share some other details about your business, how many people work there. As I say, I've read 40, you can correct me if I'm wrong.
Sure.
Any turnover stats or any sales stats or any projections or anything that you can share with us without getting yourself into trouble?
Sure. Yeah, absolutely. So you are right. We are, I believe the number is 42, although if we talk again in a week, it will be different. Recruiting is half of what we're doing right now. I joined the company about almost a year and a half ago at this point, and I was in the first 10 employees, and so we're already up to 42. So you can imagine, that is a very rapid clip, and most are in engineering. Our product is, quite complicated. It's very, it's heavy computer vision software. We are making our own hardware because that's something that we have to do in order to, get the safety certification that I mentioned before. But really the bulk of it is in the software. And that's really where our patents lie. And a lot of the magic really falls. So most of our team is, software engineering.
And what are the main sectors or types of customers, or maybe even specific customers that you're aiming for or anticipate doing well in? Automotive, you've mentioned, obviously that's a huge area.
Yeah, so the simple answer is anywhere you find those big robots is really our market. So certainly automotive is big, and we've done work with automotive OEMs, and we've done work with multiple, tier one, component suppliers. But it really, we also have done work with white goods manufacturers, consumer packaged goods companies, especially on palletizing applications. They use very big robots to move, heavy boxes of things like detergent around. And so that's a very interesting, widespread application for us. We even have one of our first customers is in the oil and gas industry. So we're really, kind of industry agnostic. It's anywhere, people are using those big robots. And even within that, we think that, we, similar to, Power and Force Limited robots, but, a bigger scale, we enable people to put robots in places where they couldn't before. And so one, kind of area of interest, and we talk to the robot OEMs about this, from time to time, is in final assembly in automotive. So there's a lot of robots in automotive, but when you get to final assembly, it's actually mostly manual. And so, being able to, have some robots in there, helping people with the manual tasks, we actually think is a very big opportunity as well.
One of the things that another salesperson told me, which was quite interesting, it's probably not the only one who told me this, but he did say with new solutions, one of the most complex things is to kind of come up with a solution, to explain the solution, to apply the solution. As I say, he was in sales, even though he's not a technical person. That a lot of that kind of work is involved in sales of this type. I don't know if you agree with that, and what kind of experience have you had in that respect?
Absolutely. In fact, my background is varied. I've done sales. I've also been involved in product strategy and product management, and so all of those things actually play into what is considered sales for an early stage startup. So much of it is, really understanding what are the customer's needs. What are the applications. What is the right way to explain what we do, getting that constant product feedback. We've done trials with customers where really the goal was for us to spend time on an application with them in their lab and getting product feedback. We definitely don't want to be, you can't be, one of those startups that just goes into a hole and says, calls it stealth mode, and pops up, with the solution. Every single thing about it, you have to get customer feedback. And so finding in the early days, those customers that are willing to be, what I call, and I read this somewhere a while ago, but teacher customers, is really, really important. People who are willing to spend the time and invest with you, let you kind of ask the seemingly dumb questions, put the first versions of things in front of them. Our first spec sheet, I had some, teacher customers that, I said, this is our spec sheet. Is this the right level of information? Does this make sense to you? So it is a very, very iterative process, but it is something that is absolutely critical. So yes, I was hired to do sales and business development. I've been around, for a year and a half, and we haven't technically started selling anything yet. But I have been very busy working with customers to make sure that we're on the right track in the right way, with what we're building.
Is there something about the solution that is new that you provide that previously wasn't there?
Yeah, we really believe that what we're doing is quite different and revolutionary, and I think customers agree. with that. There are other ways, to safeguard work cells. You can use, light curtains and area scanners and things like that. So it's not only fences, as your option. But those things are not dynamic. They don't work in a 3D space. They can't tell when things have come in and when they have gone out. It is, you have to calculate as a manufacturing engineer, you really have to calculate the, geometries, and figure out sort of, the worst case, kind of distance. And so it doesn't really enable collaboration. So, we really feel that, enabling this true human and machine, interaction with the big dangerous robots is actually, quite new, and it is complicated. It is something that has a much heavier software component than most things that are typically, in a work cell. And it's important to understand how our system makes decisions in order, for people to, feel comfortable and trust that it is indeed safe, and they know how, the robot is going to respond in this situation. But the good news for us is our customers are manufacturing engineers. They're quite technically competent, and they're curious, and they know how to ask questions and get down to, the meat of how something works. And so in that way, I would say, we're actually quite fortunate.
Are there other companies that are doing this kind of work in terms of, the technology offering to make traditional robots easier and safer to work around, or anything like that?
We do not see any direct competitors right now. We're out there in the market. We're working with, like I said, the robot, OEMs that have their finger, on the pulse of the market as well too. Our VCs obviously are doing that. And we really think that, there isn't a direct competitor. Now that'll change. The good news is we have, patents all up and down this thing. And so it'll be difficult, but, we understand that anytime there's a good opportunity, others will follow. And so we're always asking, people if they've seen anything. But really the truth is right now, there isn't anything quite like what we're doing at Veo.
How are you finding working in this sector and doing this kind of work that you're doing? Well, the reason I ask is because robotics is quite an advanced technology, and even though it's been around for decades, people still kind of are intimidated by it somewhat. I mean, as a journalist, I am writing about it. I don't always feel 100% sure.
I have to say it's fascinating. I mean, all the things that we use in our daily lives that you completely take for granted. I mean, I have the luxury of being able to walk around factory floors, almost weekly, and actually see how things are made. And I have 3 kids. I have 3 young boys, and so I come home with stories all the time, of what I saw or how things are made, and the big robots that I'm working with. And I'm not gonna lie, it's kind of fun that they're kind of impressed. So I think it's great. I mean, I think in general, anytime you're in, a new industry, there's obviously a lot to learn. People give you a grace period for a period of time to ask all the questions. And so you've got to make sure, for that first period of time when you're the new one, that you just ask and learn as much as possible. But it isn't, while there's a lot for me to learn, I'm also in a place where, I work at a company that's doing something new, and I tend to know more about that, in the beginning, than they do. So it ends up being a very fun and interactive, exchange. So I'm learning every day. I like to think I'm teaching every day. And I just love it. I really do.
Yeah, that reminds me of a program, How Things Are Made. I mean, everybody loves that. It's such a
That's my life.
popular program. Yeah, that's why so many people are interested in robotics, because they do make things in a really interesting way.
Yep.
And all right. Well, thank you very much for your time.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, We have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.